I want to discuss some basic things about design and analysis of algorithm. Can anyone tell me about what is program or algorithm? Can anyone tell
Yes,
about
a
what is
program
program?
is just a set
Some
of
basic.
instructional codes, basically line of codes.
Okay.
And algorithm is the way they should start and end in a proper way.
Okay. Anyone else?
Actually,
Yes, yes.
actually, algorithm is nothing but it's a step-by-step processing to solve any problem.
Okay.
It
I
is a
think
set of instructions, which is, let me say, scripts, which is executed by computer to solve a problem.
okay. All of you are graduate students of computer science.
Yes.
You have graduation in computer science.
Yes, sir.
Okay.
Yes, sir.
Yes, sir, yes.
Okay.
Yes, sir. Yes.
Means you know about some basics of computer science. Okay. What is algorithm? Okay. Algorithm is simply a set of rules. Okay. To design or to execute a particular problem. Suppose you have given a problem and I want a meaningful execution for that, meaningful output also. Then what will be the steps? What are the steps for that to solve that particular problem? That is called your algorithms. Okay. Algorithm words is simply that is your step-by-step rules, either for calculations, others for different operations. That maybe you are adding, subtraction, multiplication, and anything. It is basically a Latin word, algorithm. Latin word was your algorithmus. Okay. And between 400 and 300 BC, the Greek mathematician Euclid, he invented an algorithm. The first algorithm was your GCD divisor algorithm that was used to find a GCD of two positive integers. So algorithm is simply a set of rules or set of steps to complete a task in a simple word. For example, you want to make a cup of tea. For that task, you have also an algorithm. Then what will be the algorithm? Then algorithm will be the number of steps, which type of steps in that task. For example, suppose first step will be your add water and milk to the kettle. That will be first step to make a cup of tea. And then after that you boil it and to add some tea leaves on it. That will be the second step. In the third step, you will add sugar and then serve it up in different cups. That will be the third step. These are different three steps to execute a particular task. The task is to make a cup of tea, and the algorithm is the different three tasks. For a complete problem, for a particular problem, for any problem, there may be many algorithms. Many algorithms. For a single task, for a particular problem, there may be n number of algorithms, n number of steps to execute a particular problem. So, a set of steps to execute or to complete a particular task that is described precisely enough that a computer can write it. Computer can run it. Precisely means it is very difficult for a machine to know that how much water, how much milk is added in this tea making problem. So every step, everything will be described very precisely in the algorithm. Okay, so for a particular task or a particular problem, there may be a number of algorithms, and algorithm is a set of rules for carrying out calculation either by hand or by machine. It is a defined computational procedure to execute the number of instructions or steps to achieve a particular output. That is called your algorithm. Is every algorithm which we design for a task, is it a correct algorithm? Or what will be the characteristics of any algorithm? Which line of codes, which line of steps are called a algorithm? There will be some characteristics or some properties that makes the number of steps algorithm. Algorithm is not a complete coding. It is not a complete coding instructions. It is a sequence of tasks. There is a difference between program and a algorithm. Program is total number of sequence, total number of instructions, coding, that is program. But algorithm is a sequence of tasks in written common language, in your English-like language. That is algorithm. And a program under execution, that is process. There are three different things. Algorithm is the sequence of tasks, and program is a sequence of complete instructions coding to execute a particular task. And algorithm is written in a common language. And for a program, there is any programming language. But in algorithm, we can write in any language, any common language. It is not dependent on any programming language. Algorithm never depends on a particular programming language. For a number of programming languages, there will be one unique algorithm. It is completely independent on the programming language. So for a good algorithm, for best algorithm, it must satisfy some characteristics on some properties. The first property is input. The algorithm is called an algorithm if it must have a finite number of inputs in that algorithm. Algorithm must have finite number of inputs, and there should be at least 0 or 1 input in the algorithm. Algorithm must have inputs. And another is your output. Algorithm must be some output produced as a result of execution in the algorithm. It is not possible that it cannot produce any output. If it is not producing any output, then what will the relevance of an algorithm? Why we are using an algorithm? So there must be some output. At this time, we can't say that at least 0 or some output. There must be some output produced as a result after executing that algorithm. And algorithm must be finite number of steps. That is definiteness. Algorithms must have finite number of steps. It cannot be like that infinite number of steps are in the algorithm. If there are infinite number of algorithms in the algorithm. That is not algorithm, and that is not polynomial time executing algorithm. And every algorithm must be very basic and essential, is must be very effective, and every step in the algorithm should be very effective and essential and should be very basic. Then that is an algorithm, because algorithm is steps that is written in your common language. A person who doesn't know the coding that can also understands the algorithm. What is the algorithm? Finiteness, this is very important. It must have finite number of inputs, finite number of outputs, finite steps. Algorithm must stop after a time, must stop eventually. It cannot be that you are executing any problem and it is executing infinitely. If that is doing, that is not an algorithm. Algorithm must have an endpoint, must have abort condition. If stopping is, if abort is in the program, it means it has produced the expected output and the solution and the response is possible. So algorithm must be finite also, and algorithm should be very general. Okay, it is also able to solve different several many cases. It should be understandable also, and it must be unique. It should follow the uniqueness such that each instruction of the algorithm that is not ambiguous. It is very clear. Either you will read your compiler design or your algorithm. There is no concept of ambiguity. If there is ambiguity in the code or ambiguity in the steps in algorithm, then it will not be terminated properly. So algorithm should follow the uniqueness such that each instruction of the algorithm is unambiguous and very clear. Okay, this is the algorithm. Algorithm is a finite sequence of steps which are used to solve a particular task. If the algorithm follow these characteristics, these properties, then it is called a proper algorithm for a particular problem. Otherwise, that is not a algorithm. That is not an algorithm. For a given problem, you have written 4 to 5 algorithms. Then how will you say that which algorithm is best for a particular task? How will you decide which algorithm is best? You have such parameters that you can say that this algorithm for this task is good or not. Then how will you define that which algorithm is best for a particular problem? Which solution is more suitable? Sometimes you say that for a particular problem you have two solutions, but for some inputs solution A will give best result. For some input solution B will give best results, but after some time when you change the number of inputs it will work vice versa. Then it will just interchange. Then solution B will be the best result and solution A will the worst result. Then how will you decide which algorithm is best? That is very important. As your course name is Design and Analysis of Algorithm. At first, What is algorithm? Then how will you design an algorithm? What are the steps to design a particular algorithm? The third thing is analysis, design and analysis. After designing a particular algorithm, how will you analyze that a particular algorithm is best? Which solution will be best for a given problem? Yes, can anyone tell me how will you analyze any algorithm? I think you are already software developers. Anyone who want to discuss? Am I audible?
Yeah, sir. I have a question about the algorithm. How
Okay.
and what is the usage of algorithm in computer science? For example, it can't do anything without algorithm, or it's available, we can do some task without algorithm.
Okay, I'm asking about how will you analyze? Yes, Irsad, Atal, you are telling something?
Yes, in algorithm, in case we have two algorithm for a problem, so we have to care about its time and memory
Yeah.
consumption. So we have to care about time, how much time each algorithm will take. So any algorithm that use less time or less memory, so that will be the best algorithm in our case.
Very good. Nowadays, we have a lot of memory. We have enough memory to store data. Okay. But we have no time. When someone asks for some task to you, you will say that, sorry, I don't have time, so much time for that. Like that. We don't have so much time to execute a problem. Still, we have a lot of problems in the world which cannot be executed in a linear time and which are continuously executing from years, and still we don't have any output of these problems. We are still executing. So time concern is very important, as well as space. How much time the algorithm will take to execute and how much space it will take to execute. Then we analyze the algorithm. The analysis of an algorithm finds the suitability of it in terms of either your time. On the basis of these two factors, either your time and space, we evaluate the performance of any algorithm. The algorithm performance is evaluated on the basis of your time, space. According to these factors, we analyze the algorithm, that which algorithm is good, which algorithm is best, which is an average for a particular problem. To analyze a problem for a given problem, there is more than one algorithms that can be designed. So one algorithm may be better than other. Then there is a comparison between these two algorithms. Then this comparison is done by your running time. Generally, the use time defined by the time taken by the algorithm to generating a particular output, a desired output. That is the running time. Generally, we say that an algorithm which takes less time, that is the best algorithm. Generally, you talk about that. Any algorithm which is taking you less time, that is the best algorithm. But that may differ for a given number of input. Sometimes it may be that for 10 to 15 input, it is working differently, and after 15, it is working differently. So you can't decide after giving 4 to 5 input that which algorithm is best. So you have to check for many number of inputs that which algorithm is best. But generally we say that algorithm is better if it takes less running time. The time means it doesn't mean your clock time. Okay, this is not the your hardware is you are using. The running time of an algorithm can be represented in terms of the operations executed for a given input. It is not your hardware clock time. It is the number of operations executed for a given input. It means more the number of operations, the larger the running time of algorithms. So if we can find the number of operations required for a given input in an algorithm, then we can measure the running time. After finding the number of operations for a particular problem, then we will decide that what is the running time, not according to your clock time. This running time of an algorithm to generate a particular output, this is called your time complexity. Now this is called your time complexity. Time is not your clock time. It is the number of operations, the number of operations executed for a given input. And most number of operations executed in larger number of times for algorithm, it is that time. That is called your time complexity. Means how much a program, how much an algorithm is complex according to their time. So two algorithms can be compared in terms of your time complexity. Algorithm which have a smaller running time, which have a smaller time complexity, that will be better in compared to different. And the running time of the algorithm, it is denoted by your T of n, T function n, T of n. And you have different generalized form of running time for any algorithms. You may have constant time. Constant time means in order of one time. Constant time, it means you are executing a problem. You are running time of any problem f which size is n. It is executing in a constant time, in a linear time. It does not depend on the size, input size. It is taking a constant time, very less time to execute. If the running time does not depends on your input size of the program, of the algorithm, then it is called your constant time. Either can be the running time can be your linear time. Some algorithms takes your linear time, or that is your order of n. For example, for searching a particular element in a given array, how much time it will take? I want to search a element in a given array in linear search. Then how much time it will take? It will take maximum n time to find out a single element from a given array, because there are n number of elements in the array. Then maximum it can take order of n time. That's just linear time. If the time complexity is at most a constant factor times of the size of the input, then it is called your linear time complexity. For example, I have already told, to find out a particular element for a given array, it will take order of n time, because in a single pass, it will travel from 0 to n minus 1 location. It will travel total n time, n numbers. So it will take n time to find out a particular element. In worst case, if I am talking about any complexity, then I will talking about the worst case complexity. Then the complexity may be also at logarithm time, log time. If the time complexity of any algorithm, that is your proportional of the logarithm of the input size, that will be your time log and complexity. For example, in binary search, in linear search, the complexity to find out a particular element, that is your order of n time, because you have to find out a single element in a n size array in linear search. Now you want to search an element in binary search algorithm. In binary search, there is already a sorted array. To find out a particular element, every time you find out a middle element. The middle element have middle value. From that middle value, the left side's elements are less than from the middle element, the right side elements are greater than from that middle element. At this time, if the key value which you want to find out in the right side, you will move to right side, otherwise you will move to your left side. Then you will find out the accurate value, accurate position after dividing the problem into some small problem. Every time you have divided your problem into just two equal halves. So it is proportional to the logarithm time, because when you divided a problem into two subproblems, then two subproblems, further two subproblems, then the height of that tree will be your log n. The maximum height of your tree will be log n, and you will travel maximum log n time to find out a particular element, because the height of that tree, the height of that binary tree, that is your log n, and you will travel maximum log n time. Then the complexity is called your logarithm time complexity, log n complexity. All the divide and conquer approaches, such as your merge sort, quick sort algorithms, these algorithms, all the divide and conquer technologies, techniques, algorithms, that takes your logarithm time, because in this approach, every time I divide the problem into subproblems and to find out a particular solution. After finding the solution, I conquer those subproblems into a single problem. And I have to travel maximum log n time, because that is the size of the problem. So the time complexity of such type of algorithm will be proportional to the logarithm time of the input size. That will be called your logarithm time complexities. And some algorithms may run in order of n square time, quadratic time. If for a particular algorithm, for a given algorithm, you have nested loops. Nested loops are loops inside loops. For a single for loop, there is one more loop inside that for loop. There are more than one loop. There are nested loops. Then the complexity will be order of n square. If there are two loops, two nested loops, then the complexity will be n square, because for a single value of n in the outer loop, the inner loop will be executed your n time. The outer loop iterates order of n time for each iteration of the inner loop. That takes also order of n time. So for single iteration, the inner loop will be executed n time, and for n iteration, the overall execution, it will take your n into n order of n square time. For example, if you are sorting an array, there are n numbers and you want to sort that array. It is not possible to sort any array in a single loop. Then you have to execute this problem in two loops. Then there is a requirement of two loops, nested loops. For a single iteration, the inner loop will be executed n time, and for n iteration, it will take n into n time. The total execution time will be your n into n. That will be your order of n square time. So some algorithms may take your quadratic time for execution. I am talking about your time complexities. And some algorithms may also take your n cube time, cubic time. In these type of algorithms, you are also using nested loops, but in these type of algorithms, you are using 3 nested loops. And for each loop, the inner loop is executing n times for a single iteration. So total, it will take, for a single iteration in the outer loop, it will take n into n iteration. So total, it will take n into n into n iteration, total n cube iteration. For example, if you are doing your matrix multiplication, in the matrix multiplication, when you develop the program for matrix multiplication, you have used 3 loops, I, j, and k. In matrix multiplication, you have used 3 loops. So in 3 loops, for a single iteration of I, j will execute n time and k will also execute n time. So for a single iteration of I, j and k will execute your n into n time. That will be your order of n square time for a single iteration. And for n iteration of I, it will execute your n into n iteration. That will be your order of n cube. So the complexity of matrix multiplication is always your order of n cube. But when you divide your matrix in different quadrants, then the complexity of matrix multiplication is n to the power 2.86. That is called your Starson matrix, because in Starson matrix I have divided the complete matrix in different quadrant, and then I have calculated the number of iterations. After the number of iterations, I have find out the time complexity. Then that time the time complexity was your 2n to the power 2.86. That is your matrix multiplication through normal 3 loops and through 3 loops with the help of your Starson matrix. That is your time complexity. Sometimes an algorithm may take your polynomial time more than n cube. This running time is obtained when the search over all subsets of a size is performed. You have many different subsets, and size k of n elements can be chosen. For that, we have taken a combination of n elements at a time. For example, such as your graph theory, you have to find out, you have defined a set of nodes in which no pair of nodes have an edge between them. You have find out the independent set of problem in a graph. Then you will use your brute force method to solve the problem or searching of all subsets of k-nodes in the graph. Then you cannot solve this problem with the help of in your cubic time, your normal time. Then you will take your polynomial time and to the power k time, exponential time, your factorial time to execute such type of problems. In later class, we will also discuss these problems, your polynomial time problems, your non-polynomial time problems, your NP problems, P problems. There are many problems, NP problems, which a computer cannot execute in a linear time. Even many problems which a computer cannot execute. There are so many problems like that. So running time or time complexity depends on your input size, how much number of steps, how many instructions, how many number of steps are in the program, total input size. It depends on this. It does not depend on your clock time, how much time it is taking, 2 minutes, some nanosecond, milliseconds. Okay, so this analysis of algorithm that was introduced by Donald, and Donald also written 5 very interesting books, Donald in algorithm. You can read this. For a different technique, he has written a different book. For searching, a different book. For basics, a different. For sorting, a different book. For divide and conquer approach, a different book. Dynamic programming for different books. So he's introduced the complexity, the analysis of algorithm. So for a particular problem, I'm calculating the time, the running time of any algorithm, which is called your time complexity. So it will take your different time for different number of inputs, as I discussed earlier. For different input, it will work differently. If I am changing the input, it will work differently according to the input behavior. There are 3 cases in the analysis of your algorithm. These cases are your worst case, best case, or average case. Worst case is your maximum number of steps taken of any instance of a sizing. Maximum numbers, maximum time, maximum number of instructions that is taken to execute a particular problem. That is called your worst case. And best case a minimum number of steps. Minimum number of steps are taken to execute that problem. That is best case. And next is your average case. Average case is the number of steps taken on an average for all the instances of the size. That is average case. For example, let us take this fundamental searching technique that is called your linear search. In the linear search, to find out an element from the size and array, what will be the worst case, what will be the best case, and what is the average case? What will be the worst case? Worst case will be if I am searching for an element and it is in the last position, if it is in the last position, then that is the worst case. Then how much comparison it will do? It will do total n number of comparison, because the element is found in the last position. So it have to run total n time. So worst case of the searching, linear search, basic search, that will be your n, order of n. And what will be the best case in that example? If I am finding a particular element, key element, that is found in the first position, I am searching for an element and that element is in the first position. First element is that required element, then that will be the best case. So the best case will be order of one time in the constant time. In the constant time, I have to find out the solution. So linear search, the worst case will be your order of n. That is your big O of n, order of n. And best case will be your order of one, constant time. In the constant time, is giving the output. And what will be the average case? The average case will be if the element is found in the middle case, in the middle, after middle position, after before mid position, that will be the average case. That means not it is found in the first position, not in the found in the last position. Then what will be the complexity? The complexity will be constant time plus maximum time divided by 2. That will also be your order of n, because in the algorithm I generally ignores the constants. So we can also say that the average case assumes the your worst case approach. In not all cases, but in some algorithm it is similar to your worst case. I think it is clear to in the linear search algorithm, the example. Okay, and the worst case is defined by your big O notation. We use to calculate the complexity, to measure the complexity. I use some notations. For example, to measure the length, I use meter. In algorithm, to measure the time and space complexity, to measure how much time it is taking and how much space is required to store the number of steps, the number of instructions, that is denoted by your notations. The worst case is denoted by your big O notation, that is called your big O. Actually, this notation is used, your upper bound, maximum steps, maximum number of steps required to solve a particular notation. That is your big O. And best case, that is denoted by omega, big omega. This is your least number of steps, minimum number of steps required to solve a particular problem. This is also called your lower bound of an algorithm, big omega. Big O is your upper bound, maximum time, maximum number of steps it is taking to execute a particular problem. That is big O. Big omega, minimum number of steps. It is also used to express the lower bound of that particular problem. That is big omega. And for average case, that is also used to express both upper and lower bound. That is called your theta notation. So there are three types of notations that are used for these complexities. These are called your basic asymptotic notations, which are used to express the running time of an algorithm in terms of the function. If I am expressing the running time of an algorithm in terms of the function, then I use three basic notations, three notations. These are called your asymptotic notations, where the input size tends to your infinity. Okay. For worst case, it is take maximum and time. In case of linear search, that will be the upper bound or maximum number of steps. And lower bound, minimum number of steps, that will be order of 1 constant time for a single time. And for upper and lower bound average case, it will take your also order of n time, that will be similar to your big O notations. So 3 basic notations are used for checking, for evaluating, for expressing the running time of algorithm in terms of their functions. Then how many types of problems are in algorithm? So there are different types of algorithms, computing problems in algorithms, but in your syllabus we will commonly discuss. There will be your searching algorithms in which you will find out any element. Then your sorting algorithms, you have to sort either ascending or descending orders. Then you have some graph problems such that to find out the shortest path to reach the end node, these type of problems. Some dynamic problems, dynamic programming problems. For example, your traveling salesman problems, knapsack problems, your divide and conquer approaches which are used either your searching or sorting techniques. There are many numerical problems we will discuss further in the algorithm. Is it clear to all? Actually, this is the basic part.
Yes, sir. Yes.
I'm talking about some basics of this course. And the first unit, it is also very boring also, because this is basic and very boring. Okay. There are some common problem solving techniques we will further also discuss and which are very important. The first common technique that is used, that is also your divide and conquer approach. For example, I use binary search. In divide and conquer approach, I divide the problem at the top level problem into a set of small problems, lower levels. And in next step, I solve every subproblems, lower level problems, to find out a recursive approach. After solving the subproblems, I merge all the solutions of subproblems to a complete solution of the problem. That approach is called your divide and conquer approach. In divide and conquer approach, we will discuss binary search, quick sort, either merge sort, as it starts in matrix multiplication, which I discussed earlier, in which the complexity was n to the power 2 to the power 86, because I have divided the complete matrix into some smaller quadrants. We will learn these approaches in this approach. Next, more important technique that is used, that is called your greedy approach, as name suggests, greedy approach. Optimization problems. In optimization problems, either the value will be maximized or either it will be minimized, because I am greedy at that time to solve these problems. Either I will maximize the problem input values, either I will minimize according to my requirements, according to my greediness, according to some constraints or conditions. In greedy approach, it always picks the best choice. Always picks the best choice, either in maximum or minimized. It will always pick your best approach to optimize your objectives. And it also select your local optimum solution every step, in every step. and that decision will be depend on that particular solution at that point. At that point, what will be the solution? The next step will be the decision will be depend on this. And we cannot say that for a final output or a final greedy approach, we cannot say that it will always produce a optimal solution in every step. For a complete solution, there will be some different solution. That every time it cannot be an optimal solution in every step. For example, some graph problems, your Prim's algorithms, where you will find out the minimum spanning tree of the graph. Either you have Kruskal algorithms, in which every time you take just optimal node, which have minimum weight, or either your knapsack problem, or your discuss a shortest path problem, where you travel from one node to another node with your shortest path. These algorithms are discussed in your greedy approach. Okay. One more is your dynamic programming. In the greedy programming, in the greedy approach, we have different problems and different algorithms. We can also solve these problems with the help of your dynamic program, with the dynamic programming. As divide and conquer approach is your top to down approach. Divide and conquer. I have divided the main problem into some smaller subproblem and then solve all the subproblems. But dynamic programming approach is your bottom to up approach, which involves to find the solution of all subproblems. I am finding the solution of all subproblems, saving these partial results. After that, I am talking about the original problems of solution of the original problem obtained. Every time I am reusing the result of subproblems, maintaining a table of the results. I am again doing recomputations of the same problem, such as backtracking, to calculate the final solution. The dynamic programming always takes less time, but it is a bottom-up approach. Every time I am finding some result of some problem, I am saving that result. According to the results, I am finding another solution of main problem. Every time I am using the previous result, reusing the results of the subproblems to find out a particular problem. So it takes much less time. The working is similar to divide and conquer. In divide and conquer, we are also dividing the problem in the first part, but at last we are finding the solution of the at the lowest level in divide and conquer. But we are not using that result for another one. But in dynamic programming, it is similar to divide and conquer approach. Every time we are saving that solution until we are not find the original solution or particular problem. Both our problems are breaking it down to several subproblems. We will divide the problem until it becomes minimum. What do you mean by minimum? Minimum means after that we cannot divide it. That is the minimum in terms of your algorithm. After finding the solution in the minimum element, then it is solved recursively. But there is some drawback in divide and conquer method is calling a recursive function with same input output repeatedly. Divide and conquer, every time if I'm doing merge sort, every time recursive call merge procedure is called recursively. Every time it is recursively called merge procedure. But this is overcome in the dynamic programming. because it's maintained a table. It maintained a table to store the previous result. For a solution, it maintained a table, and when I required that, it used the result. It is dynamically decided whether to call a function or retrieve the value of the table. It will never call a function again and recursively call a function, but it is dynamically decided either it will call a function or directly retrieve the value from the table. It is not necessary to call recursively a function. This is the difference between dynamic programming and divide and conquer approach. So dynamic programming is faster in comparison to divide and conquer approach. If I am using same procedure, recursive functions, I have to call recursive functions recursively time to time in the dynamic programming, that there is no difference in the running time. Either it will be your dynamic programming or in the divide and conquer approach. But in dynamic programming, it is decided randomly, it is decided dynamically. Either it is retrieved from the table or it is the requirement of calling a function. So the dynamic programming approach, it is faster than divide and conquer method, because the redundancy is in the calling function. The same result is omitted on it. For example, knapsack problem. Not simple knapsack, 0-1 knapsack problem. In 0-1 knapsack problem, either you have to take all, either you have to take 0. That is solved with the help of dynamic programming. Either you can say you subset some problem where you have to find out the subset of n numbers for a particular sum. Then this is best algorithm, best programming technique which is used, and it will always take you a minimum time to solve a particular problem. These are some basic techniques, and one more technique that is also used, that is you have heard about that n queens problem. In the chess game you have n queens problem, that is also called your backtracking algorithm. Backtracking algorithm is like as you are creating checkpoints while exploring your new solution every time you create your checkpoints. And it works on your DFS mechanism, depth first search mechanism. In backtracking algorithm, search all the possible solutions until it is exploring the solutions. You search all the possible solutions until it doesn't find a particular solution. During this exploration of solution, if the solution doesn't work, it will backtrack to the previous place and then find the other alternatives. It will find other alternatives to get a particular solution. So there are many checkpoints, there are many choices if the particular single search fails in the backtracking algorithm. For example, n queens problem in the chessboard. In the chessboard, you are moving. If there is another queen in front of you, then what will you do? You will be in the backtrack. These type of algorithms, which will search your all possible solutions. If the solution is not good, it will backtrack to the previous place and it will search for other alternatives to find out a particular solution. These type of algorithms will call your backtracking algorithms. Okay, so this is algorithm characteristics of algorithm, and how will we analyze the algorithms. What are the different types of algorithm? What may be the algorithms? How these algorithms is analyzed with notations? What are the notations? Okay, this is the fundamental of your design and analysis of algorithm, which is very important for further classes. Is it clear? Is it clear?
Yes, thank you so much. That was good.
Yes, sir, it's clear, sir.
Actually, this is fundamental. This is very important.
Sir,
So
you are
what?
not sharing the screen.
Sir, can you hear?
Yeah.
Sir, yeah. For many respect, it would be really nice if you share, the PDFs at the time of lecturing. It would be really appreciated and nice for us, I think. Yeah.
From
Thank
next
you.
class, I will also prepare some PPT for you. Okay. Actually, design of analysis algorithm, it is purely based on your mathematics. Okay. It is not possible to teach you only in the lectures. We have practicals also. Okay. I will try with the help of
Yeah,
any
yeah.
simulator.
Yes, sir, that's right. If you share, the units which will
Yeah,
already
yeah.
shared in LMS at the same
Mm.
time of lecturing, it would be really nice for us to that we know which topic you are lecturing or you are describing. I think, yeah, that's
Yeah,
why.
because this is your fundamental basic class. I have just cleared the few basic fundamentals of the program of the course. Okay, from next class I will try to simulate the algorithms also. Okay, with the help of any simulation, online simulation. So
Sir,
simulation.
Okay, sir.
mm, yeah, sir, that is that is very good if you have PowerPoint slides
Yeah,
shortly
I
from
will.
all the lesson during the lessons you explained that.
Yeah, I will do that. But definitely I will do that. Okay, because this
Thank
is just a basic fundamental, and in the fundamental class, I think that it was not necessary to write down all these things in the PPT. Okay,
thank
so I
you.
have not prepared PPT. But from the next, when we will discuss different techniques, different approaches, then there's a need of an PPT and some programming simulators where you can see that how the algorithm works. Okay, is there
Yeah,
any queries?
thank you.
Okay, okay, you may leave if it is okay to all.
Hello?
Yes, any queries?
No, sir, I want to ask,
No, thank you, sir.
you
Today
continue
class is
your
over.
lesson or finish that?
Oh, okay. Today class is over. Okay, we will meet soon.
Okay, thank you.
Okay, you may
Sure.
leave.
Thank you, sir. Bye.
Thank you. Bye bye. Okay, class, you may leave. Okay, we will meet in the next class.
Can you hear me? Hello? سلام دوستای خوب هستین؟ صحت شما خوب است؟
تشکر. سلامت باشه آقای استانکزی. درس تمام شد فکر کنم.
سلامت باشی. زمین سیب ببخشین بعد می کسی آمد در دفتر بودم امروز که از دیگه مصروف شدم. بر ما کدام وظیفه خانگی یا کدام رفرنس دادن که بخوانمش به خاطر الگوریتم یا تمام چپترهایی که اینا اپلود کردن نمی کافی است. یه بارش دیگه
نه، در مورد MCS211 از بخش الگوریتم یک معلومات بسیار مختصر دادم و چیزایی که اینا گفتن کلش در بخش های اول از اون چپتر اگر مرور کرده باشین کلشان است. یک کمی توضیح دادم در موردش، دیگه چیزی نگفتم.
فقط هم قدر گفتن الگوریتم کدام الگوریتم بهتر است.
یعنی کل از اون مواردهایی که در اینجا گفتن در این چپتر یونیت یک بیزیک آف ان الگوریتم and its properties کلشان است. کل از این گپایی گفته شد در اینجا موجوده.
سیکونس سلکشن و اتریشن چیزا
بسیار درس بیزیک ابتدایی بود دیگه.
درست است. تشکر از این.
موفق باشه. خداحافظ.
ببخشید این
Hello. Bale.